It is time to talk about the unit circle. Some trig textbooks will use the unit circle as a way of defining the trig functions. I use it as a way of understanding them a little better. I'll show you why. Well, first of all, the unit circle. What the heck is the unit circle? Well, first of all, it's a circle. And the unit part of it means that it has radius 1. And there's a lot of circles with radius 1, so to say the unit circle as opposed to a unit circle, to use the definite article here, means that we're picking the very special unit circle that is radius 1 centered at the origin. How did I do? Not very well. Let's try that again. Here, let's move this over a little bit. There, that looks better. So it hits the x and y axis at 1 and minus 1. Right? And if you want, the equation of it is x squared plus y squared equals 1. That is the unit circle. Okay. And what we're going to do is we're going to see how this helps us with our trig here. So I'm going to put an angle in standard position. So initial ray is here on the positive x-axis. Terminal ray is out there. Okay. So there's the angle theta here. Okay. Now, one thing is that the radius here is 1. And so if I look at the arc length, well, the arc length is always equal to the radius times the angle, provided that the angle is in radians. And I think from now on we probably want to stick with radians with a lot of the work that we do, so we'll get some practice with that. Well, in this case, with r equal to 1, this is just equal to 1 times theta, which is just theta. Curious thing, in the unit circle, the angle and the arc are the same number. This is radians, this is inches or feet, whatever you're measuring your length in. But if this is 1 mile and this is 0.5 radians, and this is 0.5 miles over here, that numerically the angle and the length of the arc are the same. Okay, we're going to look at trig functions. We're going to look at like the sine of theta and the cosine of theta. And one thing that you'll see in some textbooks, in fact, if you look back historically, that because of this relationship between the angle and the arc in the unit circle, that sometimes they might say sine of s, cosine of s, where they're plugging the arc length into the trig function, into the trig functions. We think of angles as being the input to the trig function. Others think of the arc as being the input to the trig function. Well, as long as you're in the unit circle, the angle and the arc are the same, so it really doesn't make any difference. Okay. Anyway, here we go. I want to look at the coordinates of this point right here. The coordinates of that point right there, I can see very clearly if I drop a perpendicular down to the x-axis. I don't know if I've ever said this before, but I want to drop it to the x-axis, right? The x-coordinate, let's see, this point here has coordinates xy. The x-coordinate is going to be this length from here right over to there, which maybe, if you know some trig, this angle, those two sides, the cosine of this angle should be x divided by 1. Well, goodness, if cosine is x divided by 1, then x is going to be cosine theta. Likewise, the y-coordinate is this side up here, and that turns out to be the sine of theta. So the coordinates of that point are cosine theta, sine theta. So the sine of theta is the y-coordinate there. The cosine of theta is the x-coordinate. It's really y divided by 1, and cosine is x divided by 1, but the divided by 1 doesn't really do anything. Likewise, you can see that the tangent of theta is y divided by x, right? This is the way a lot of textbooks define the trig functions. They say, take an angle, put it in standard position. Look at where the terminal ray crosses the unit circle. The x-coordinate is the cosine of the angle. The y-coordinate is the sine of the angle. That's the way they make the definition. To me, this just feels so wrong because trig functions should be ratios of sides. And just to say it's the x, cosine is the x-coordinate and the sine is the y-coordinate, and just saying, oh, that's the side. This side is the cosine. This side is the sine. It's like, no. This side divided by 1 is the sine. This side divided by 1 is the cosine. Okay, I can live with that. Anyway, there we go. That's the unit circle. That's the definition of 3 of the trig functions using the unit circle. I don't really think of it as the definition from my point of view. This is, if I put a triangle here and have hypotenuse 1, then that tells me what the trig here tells me what the two sides are. Right. This triangle in here, I've probably drawn before. There's a theta there, there's a 1 on the hypotenuse. This is the sine theta, this is the cosine theta. Notice that I'm sure I've mentioned this before, that the cosine squared theta plus the sine squared theta is equal to 1, right? That's the Pythagorean theorem on that. Well, also up here, if you look at the equation of this circle, x squared plus y squared equals 1, well, the x squared is cos theta, the y squared is, x is cos theta, y is sine theta, so they're just plugging in the x and y coordinates into the equation of that unit circle. Okay. So even though we may not have thought in terms of circles before, just that Pythagorean relationship, cosine squared theta plus sine squared theta equals 1, is really talking about, or you can think of it as talking about the equation of a circle, and you're just looking at x and y coordinates. Okay. We will use this circle in a bunch of ways, but not as a definition, right? We know that the sine of theta is y because opposite divided by 1 should be the side of theta. So that's got to be sine theta, and so on.